Net zero. It's a phrase we hear everywhere. But what does it actually mean? Today I want to discuss net zero and common misunderstandings for net zero and talk a little bit about different factors within net zero, such as the carbon cycle. The purpose of this video is to explain net zero, talk about its contemporary issues, and how it is used to combat climate change. So, net zero is all about balance. So imagine a set of scales. On the one side, you have emissions, right? And this is the greenhouse gases we put into the atmosphere from burning fossil fuels, farming, and deforestation. And on the other side, we have the removals. That's the ways in which we take CO2 out of the atmosphere. So that could be planting trees, restoring ecosystems, or using carbon capture technologies. Now, the goal of net zero is to make sure that these scales are balanced. So for every ton of CO2 we emit, we remove an equivalent amount so there's not an increase in the atmosphere. So this balance ties directly to how the carbon cycle works. The carbon cycle is nature's way of moving carbon around. So plants absorb CO2 from the atmosphere, animals eat plants, and when plants or animals die, their carbon returns to the air, soil, or oceans. This is part of the natural short-term carbon cycle, which has been in balance for millions of years. But here's the problem. When we burn fossil fuels, we're pulling carbon out of the Earth's long-term storage. So think of it like tapping into an ancient bank account and dumping it into the short-term cycle. This overloads the system, and then this leads to climate change. So here's an easy way to think about it. Imagine the Earth's carbon system as a bathtub. The faucet represents emissions, CO2 we're adding to the atmosphere. The drain is the natural sinks like forests and oceans that remove CO2. Right now, the faucet is pouring way too fast, and the drain can't keep up. The tub is therefore overflowing, and that represents global warming. Net zero means turning the faucet down to a trickle and making the drain work better to keep the water level steady. So here's a common misunderstanding about net zero, and that's the term ultimate zero. So what's the difference between net zero and ultimate zero? Well, net zero, this means the balancing of emissions with removals. So we still emit some CO2, but we offset those emissions by removing the same amount, and it's a necessary step to stabilize the climate. Ultimate zero, or gross zero, is the gold standard, right? And that means completely eliminating all emissions. It means shutting off the faucet entirely so that we're no longer adding any new CO2 into the atmosphere. Ultimate zero is much harder to achieve because some emissions, like those from farming or certain industries, are almost impossible to eliminate with today's technology. That's why we aim for net zero first, as a stepping stone to the real goal. So reaching net zero isn't about one big solution. It's a mix of actions. So switching to renewable energy, improving energy efficiency and adopting cleaner technology is one way. The second aspect is by removing carbon, and that's using nature like planting trees or using emerging technology like direct air capture to take CO2 out of the atmosphere. And for the hard to abate sectors, there really needs to be a greater emphasis on reforestation or projects that capture methane, slips from any sort of industry, because these are really what's going to help drive the sink to work better and for the faucet to move at a slower trickle. Okay, now coming into a little bit of numerical analysis on net zero and how do we get there. So I just want to start talking about some key facts on CO2. So total CO2 in the atmosphere. So the Earth's atmosphere currently contains approximately 3.23 trillion tons of CO2, and that's to the equivalent to a concentration of 420 parts per million, and that's the way that energy experts will measure the amount of CO2 in the atmosphere. That's a big number, right? And luckily, we don't emit that much per year because, yes, that would be crazy. So how much do we emit? Well, humans actively humans' activities such as burning fossil fuels and deforestation emit approximately 40 billion tons of CO2 per year. And that is one part. The amount of CO2 absorbed by natural sinks, forests absorb about 8 billion tons of CO2 annually. Oceans absorb another 10 billion tons of CO2 per year annually. So that gives you the net increase in CO2, right? So despite the natural absorption of 18 billion tons per year, a net 22 billion tons of CO2 still remain in the atmosphere globally, and that imbalance is contributing towards the rise of CO2 concentrations and global warming. We can talk a little bit about synthetic CO2 removal. So as of 2024, synthetic carbon capture technologies, including direct air capture, collectively remove about 1.35 million tons. And that's not in billions, because in billions, that's 0.00135 billion tons of CO2 a year. So right now, it doesn't do too much for the amount of carbon capture. And if we were to achieve net zero by 2030, which is arguably unrealistic, and a more realistic goal is by 2050, global CO2 emissions must drop from that 40 billion tons to around 21 billion tons per year. So, emission reductions from synthetic use is probably going to be in the ranges from 7 to 9 billion tons of CO2 removal per year, which will be required through, a combination of natural and synthetic methods to offset residual emissions. So the current versus the needed carbon capture. So natural sinks, your forests and oceans, currently remove 18 billion tons. Synthetic carbon capture currently contributes to negligible billion tons per year. And to achieve net zero, synthetic and natural CO2 capture must scale to a combined total of 26 to 27 billion tons. So a big effort is needed, and it just shows you the magnitude of what we need to do to stop global temperatures rising further. So while net zero is a great first step, it's not enough to truly solve climate change. To restore the planet's balance, we need to stop adding any new carbon altogether, and that's ultimate zero. So imagine a world where energy comes entirely from renewables, industries are completely decarbonized, and we no longer depend on fossil fuels. That's the ultimate future I believe we're working towards. So what can you do? So here's how you can help. Reduce your energy use and switch to renewables where possible. Support businesses and policies that prioritize sustainability, and advocate for technologies that accelerate the transition to net zero and beyond. Net zero is about balance, and ultimate zero is about shutting off the emissions faucet entirely. Together, they give us a roadmap to protect the planet. If this explanation helped, please give the video a thumbs up and share it with someone curious about climate solutions. Also, to help me grow the channel, please subscribe, and if you want to learn more about energy consulting, the energy industry, improving your consultant techniques, then this is the channel for you.